So before I jump to the lesson learned from data harmonization FAIRiCUBE, this time around I wanted to look a bit more into the process. So generally in this, so FAIRiCUBE is about data cubes, which we consider as, let's say, a harmonized multidimensional gridded data. So one reference grid, the data is hopefully an analysis ready, hopefully cloud optimized format with all the metadata filled up. Of course, in reality, as we all know, it's quite different. So we have different data formats. Most of the time, even if the data is openly accessible, it's not properly documented. There are no APIs, so you have to do a lot of manual work, and you have to combine this. That's a process we did, for example, for Vienna. Since we are in Vienna, I thought about taking this as an example. So we wanted to build urban data cube, so harmonize different data about the city. The application for this data cube is finding nice location for fly catching, so catching flies, fruit flies in particular, and analyze and correlate the environmental data with the genetics of the flies. My colleague Sonia will give you more background on this. We provided, let's say, the geospatial data processing for the other FAIRiCUBE use case. So, for example, we took several different data from Vienna and combined it. And I wanted to just give you an example of how we did it for two different data sets. So the land cover, land use data set of Vienna, of the city of Vienna, and the temperature. So for the land cover, we took the land cover map of Vienna dataset, and we wanted to transform it into a gridded dataset. The land cover, however, comes into it as a vector dataset, so polygons. So we decided to transform it into a gridded data into data cube. That the specifications of the data cube were 100 by 100 meter resolution in the national Austrian projection, and which has an accuracy of 1.5 meter, and is being in meters, like one cell would correspond to 1 hectare. So what we did is we decided to read the data and build a data cube where every let's say band or dimension of the data set of data cube is a different land cover class, and express the land cover as a percentage. So for each cell, you would know how much share of that specific class there is in that cell. This structure helps you handy for later statistical analysis, because you can get for one single cell all the shares for every different class. So, for example, here you have these 3 classes represent different degrees of urbanization. So red is highly dense buildings, blue is less dense, and green is sparse buildings. And this is how we always did a visualization of the grid. So that was an example, and then we want to combine it with other data, for example, the temperature. And here we had data coming from another source. It's another data provider, always from Vienna, Geosphere, that provides actually nice APIs, and you can download data, get data as .cdf and other formats. But they are not in national projection. It's in GS84. So and it's 1 kilometer, because usually climate data is openly available climate data is at least 1 kilometer. So we had to resample from 1 kilometer to 100 meters, and we have to reproject, and we also needed to decide on time aggregation. So all these steps are needs lots of decisions to take. So which reprojection do I use? Which resampling method do I use? Do I use bilinear? Do I use nearest inward? And so on. What time aggregation do I use? Do I use daily? Do I use sun, daylight, nighttime, and so on? And so you realize that even if the transformation steps seem simple, there are actually packed so many information and so many decisions to take. And the question is, how do you record all these steps to be reproducible? Because we are actually producing new data with this simple transformation. So that was what I was telling before about the lesson learned, that you can produce final data, but then write all the metadata, or you can just provide the recipe, the pipeline, the script that you used to produce the final data. So that was the lesson learned about using scripting rather than fixed or fine, like offline, let's say, products. Invest time in learning the APIs, because sometimes more and more often there are APIs available, but still very heterogeneous and need to be learned. And even if all these processes are complex, it is anyway easier for us as a data analyst to work with data cubes, with gridded data and harmonized gridded data, rather than keeping all the data in different formats and trying to do the analysis on different formats. Well, as we are discussing all day long, there are still many challenges about finding the right data, about accessing it. Something that also Kati already said a few times, that it's many analysis, many transformations are not so simple and are not really clarified yet. For example, let's say reprojecting categorical data or ordinal data is not so simple. And as a data user or data scientist, it's like metadata creation is we agree that's important, but it's still a big barrier. It's because it's still very time consuming. So sometimes there is no time, and the data scientists, the users, try to find shortcuts and come up with poor metadata. But we have to work to find, not only to find motivation, but to simplify the tools to document the data processing.